Hello, my name is Sadie, and I'm going to talk about soil liquefaction. How does a car sink into solid ground? The answer is soil liquefaction. According to the USGS, soil liquefaction occurs when a saturated soil is substantially displaced as a result of applied stress. Now that's quite a definition, so let's look at this concept at a closer level. Just like most substances, there is a point where soil reaches saturation, a point where it can no longer absorb water. Because soils, especially sands, are comprised of small particles of a non-uniform size and shape, the excess water flows into the cracks and gaps in between grains. The introduction of water into the soil on its own does not compromise the structural integrity of the soil. A perfect example of this is beach sand. You can stand on wet sand and it will hold you up. We even build houses on wet sand. This works because when saturated sand is compressed with a constant and stable force, the individual particles are pushed closer together. This displaces the water in between particles and forms a more stable surface that is able to bear weight. However, if the constant pressure applied to the saturated soil is suddenly disrupted, causing the sediment particles to vibrate, the individual particles are unable to condense and displace water. This causes the water in the sediment to liquefy the soil, which causes the disasters that we see here. In this example, the liquefaction of the sediment forms a quicksand-like structure that allows the cars to sink into previously solid ground. This liquefaction was caused by an earthquake that disrupted the compression of sediment particles. Now that the vibrational motion of the earthquake has ceased, the sand particles have recondensed, trapping the cars in what is once again solid soil. Now, let's try this out firsthand. I have 2 containers filled with sand, but I've added water to this one to saturate the sand. When I gently shake the container with dry sand to simulate an earthquake, surface structures move and sometimes even fall over, but they remain on the surface of the sediment. When I shake the container with the saturated sand particles begin to vibrate. Water pressure increases and rises to the top of the soil, liquefying it, and causing surface structures to sink as if they are resting on only liquid, which is exactly what's happening. The soil has liquefied, and the increased water prevents the sand from recondensing while the disruptive pressure from the shaking motion persists. Soil liquefaction can result in catastrophic damage as the ground liquefies and loses its ability to support structures. Another dangerous result of soil liquefaction is flow failures, where a buried area of saturated soil displaces or slides away from its initial position like a dangerous land river. Soil liquefaction is important to consider during construction in areas where earthquakes are common and soils are prone to saturation.